So let's get started. Hadoop on Google Cloud Platform. First of all, it's extremely fast to set it up. So if you nowadays, if you go to probably your IT company, the IT department within your company, you'll end up with the question, oh, I need a Hadoop cluster and it needs to be this big. And next up, you get a planning of 5 weeks or more just to get started. We need to investigate, etc. So what I'm going to show you later on is that it can be done in like 1.5 minutes, that you have a cluster ready for operations with your data. Another thing is Hadoop is most of the time seen as something like a low-level infrastructure thing that is happening within the whole cluster itself. Well, actually, it's quite hard being a good data engineer. But what we want is that you focus on your data and not necessarily on the infrastructure level. That's something that we can manage for you. And most importantly, you don't pay upfront like thousands of dollars. You just start, and you'll see that scaling up, scaling down is something that's very flexible and actually built in the Dataproc product. So if you go to, if you look at the landscape or the whole scope of where we are today, you can go from infrastructure to platform. What does it mean? On one side, you see on-premise, and that's actually how many organizations are doing it. They're trying it out. And yeah, so at some moment, you have a vendor for Hadoop, like Cloudera or another party, which can help you in that whole process. There are some tools like BDUtil, which actually allows you to do command line activities and create a cluster. But if you want to have it like managed, but still have control on everything what's happening in there, Cloud Dataproc is your best friend. And actually the last 3 categories are provided by the Google Cloud Platform. So let's take a peek under the hood of what Google Cloud Platform, what Google Cloud Dataproc is. First of all, you have to think in layers. The layer, which is actually quite important, is first of all, think of who's interacting with the system. Then you have the system. And then you have the ecosystem of all the things that are connected to your Hadoop cluster. I'd like to think also in Hadoop cluster because it's nothing else than that. So if you're used to working with your Hadoop cluster, yes, you can. If you want to do an SSH to your Hadoop cluster and run some Hadoop jobs, yes, you can. But you have to think in layers. And the good part is you have options. You can always go like you wanted to go, or like you did it so far. We also provide some APIs, which actually have something nifty in there, because yes, I can start a job, close my laptop, go home, and see the job finished. So that's something that's quite different with Hadoop jobs that you probably have in your cluster now. Another thing is that the Hadoop stack that we have is of Apache Big Top. That's actually like a collection of Spark, Hadoop, Hive, Pig, those tools that are familiar in the Hadoop stack itself. On the other side, of course, you have the data processing part, then you have the analytics part, and on the analytics part, you see that people plug in lots of third-party tools like Jupyter, Presto, Zeppelin to that cluster. And that's actually how we like to see that you start using it. So this is how Cloud Dataproc is in the end. So if you're planning a POC, there's one thing that's happening, I think, and maybe the people who just raised their hands can confirm it, that you start out with a Hadoop cluster, you say, okay, I have it. Then you say, okay, now we need something special, Spark, PySpark, Hive, Pig, everything on top of it. Then all of a sudden your data science say, okay, I'd like to access that data, and then they plug in Jupyter Notebook, etc. So the good part of the Hadoop stack itself is that you can augment that whole environment quite well. It's built for integration. But on the other side, it becomes a monolith in years, and all of a sudden people say, okay, it's running, I'm not going to touch it. And that's exactly why you have to think not about lifting it to a new environment, but maybe you have to rethink what you're using, and maybe you should start to figure out, okay, this is a workaround, and this is something I really need. And that's something we're going to see in a bit also. So this is what you see quite often happening which is actually not a good thing. So if you look at the goals that people can have, it's yeah, most of the times it's about cost savings. How much do I save with it? Our advice is don't go byte by byte, but look at the whole experience of it. Price performance in that context. Scaling elasticity. So multi-cluster scale out is very easy. If you want to burst for just a couple of minutes, it's actually quite easy. If you don't have that capacity and you need it at that moment, you can just say it to the system and then it will give it to you back. I'm saying say it. Unfortunately, I don't have a Hadoop demo with Google Home device, but that would be really cool, but that's for next time. Then for development, yeah, so actually if you look at this list, you probably find one of the reasons that you say, okay, that's the reason why I would like to move forward to something new, because it's becoming really expensive. Another thing that is something that you should start figuring out for yourself, because each of the environments are different, they have a different need, and that's actually also how it starts, because it's not about I have one cluster and I'm going to do everything with it. Most of the time, that is the end result of what's happening now with Hadoop in production. So what you have to figure out for yourself is what open source components am I using, what is indeed necessary, and what is a workaround. You might find some things that you say, okay, I shouldn't have done it, but now I have a new option to start doing it again, but differently. Another thing is the system characteristics. So we can natively support HBase, which is also very common in a Hadoop cluster. HDFS, of course, and many other protocols that are quite known in the Google Cloud. But again, you have to figure out yourself what is necessary for your environment. Is it about SSDs? Is it about hard disks? Is it about cold storage? Is it data that I access a lot? Yes or no? Many characteristics that are typical to your environment. And also about the timeline, your quota, your capacity. So it's very hard to say now, today. I've encountered one such situation that people had to bring in, seriously, server rack, configure it, and try to do some calculations on it or some data science. But in the end, that's not where the value is. It's not the hardware. It's not the software also. It's about what you get out of your data that is so common, so particular to this specific client. So that's why I would say another thing that's very important is how do I get my data into the system? All this runs around data, right? And we're collecting quite a lot nowadays. So if you look at the storage options, you have a couple of them. The Google Cloud Storage, which is an object store. So it has some other semantics. HDFS on Dataproc persistent disk. So if you want to have performance, but if you want to go higher in that context, you can opt for SSDs. Another thing is if you want to say, okay, fine, I don't want to manage my data at all. Then something like Bigtable, Cloud Bigtable comes in, which in fact is an HBase implementation. So everything you know from HBase can be reused in this context also. And if you really don't want to worry about the underlying part and want to use, as mentioned also in the keynote, BigQuery, which is a no-ops data warehouse solution that Google provides in the cloud, where you can do petabyte scale queries in like minutes. And it's becoming really more important because we have some customers that are generating petabytes of data a day. So then BigQuery might be another solution to look at for storage. Of course, if you look at the timeline, some people use the storage for archiving or for backup recovery. The nice part is if you try to put it in these storage options, you have an option to run ad hoc queries if you want, because you have that environment ready. You don't have to replicate a lot, so that might be another thing to think about. Okay, if you look at, so the Google Cloud Connector is, in fact, one of the cornerstones of the whole implementation if you're going to go Google Cloud. Why? Because first of all, you have to get your data in. I'm going to show you a couple of options that you have to get your data into the system. First of all, GCS and HDFS are implementations that are, interoperable. You can quite easily implement the access to your files, actually by changing the protocols to, for example, GS, //. There is a difference, though. HDFS has a different semantics, and I mentioned it a moment ago. With semantics, I mean to say that we have something called, in HDFS, we have something called directories. Cloud storage doesn't have that context. The nice part is that the world of Hadoop is starting to understand that whole concept of not having directories. Because if you look at it from a different angle, it might not make sense anymore, because we're doing like unstructured data all over the place. There is a pro and a con on that, of course, because the fact that we don't have directories and other things that are different than HDFS has to do with the fact that we want to have high availability. So it's up to you. There are ways to still do it anyhow. But for example, if you have files that are on which data is added, so they append data to it, then you might have to look into the native HDFS implementation on Google Cloud Storage, Google Cloud. So in the end, there are pros and cons, but the most important part is that you do realize that you have options. You have options to move forward also. So getting data in your system can be done in two ways. You have the push-based version versus the pull-based version. What does it mean? So there's tooling on the command line, which you can say distributed copy, and all my files are pumped into the cloud storage. That's just a command line tool that you can do. Then you use your internet gateway, and that's it. That's the easiest way to go forward. But you can, of course, imagine that a customer say, well, no, that's too leaky, although it's over HTTPS, etc. I still want to have, with my firewall rules, with my routing information, I want to have access, I want to provide my data to the cloud environment. So for that, Google provides a Google Cloud VPN gateway, which allows you to create a private subnetwork within the Google Cloud Platform, which fits your network needs for your firewall and actually creates a bridge between the cloud environment and your environment. The most interesting part is that you can query from both environments now. You can start querying from the cloud environment because it's like a bridge. You can query on the on-premise situation, depending on the firewall rules, but also from the other side, you just can query the data that's stored in Google Cloud. Does make sense. So there are a couple of options that you have here. So another result of doing all these migrations and thinking forward, and of course, if you have pain, you'll try to fix it, is to think about some bigger architectural concepts. So one of the most important things is in Cloud Dataproc is, the way we think about it is, if people start a cluster now, the first question that you get is, how much data are you going to store? So people start ramping up hard disks and saying, okay, I want so much petabytes of data for hard disks available. We in Google Cloud think differently on this context because there's a concept which is called, in Hadoop, which is called bin packing and data locality. Both things are very important when you start to implement your Hadoop cluster on-premise or in a hosted environment. But the most important part is that if you start doing that, you're adding complexity to your cluster, because managing that part is what I mentioned in the beginning. It's going to create overhead in your operations, and it's going to make it more complex. The cool part of this whole story is that the Hadoop cluster with separate storage supports bin picking out of the box, and data locality is something you don't even have to think about, because the Google Cloud can make sure that the data is close to you depending on how you start your cluster. So if you do this, there's another note that is very important. So if you divide compute and storage, if you divide those two, you can start thinking in different concepts now. Because if I say that if initially you said that the computation power of the computation hours were like 10,000 hours to, for example, do a data analysis part. You now can say, okay, so that was 1 hour, 10,000 CPUs, vCPUs, and now you can say, okay, give me 20,000 vCPUs, and in half an hour I have my data processed. Or give me 100 vCPUs and 100 hours of processing. That's up to you. The good part is you have the freedom in the end, because in the end the total cost of all those three options are the same. If you do 10,000 1 hour, 20,000 half an hour, or 100 in 100 hours, the cost for the Google Cloud Platform is the same. So now you see that you can process the same kind of information in less time, because you can burst and allocate quite some CPUs, because you make the distinction between storage and compute. Another very nice thing, and I noticed it in my demo also when I was preparing this, is the cost saving through preemptable VMs. What are preemptable VMs? So who of you are in the DevOps area, who are building and creating VMs maybe in your build process? So preemptable VMs are exactly meant for those kind of situations, because what happens is that if you build, you run a test, and then you kill the VM again, right? So normally, normally you would buy a contract or sign for a year, or have an hourly billing situation. So, and even if you use it like 10 minutes. So preemptable VMs are first of all minute-based billing. And another thing is they're like 20% of the price of an original VM, because we know you're gonna throw it away. And that's another thing. If you don't throw it away, Google has the right to reclaim that capacity. Because if you're not doing anything with it and it's not meant to live long in your cluster, and that's actually the nicest part of Google Cloud Dataproc. As fast as you bring it up, like in 1.5 minutes, even faster you can break it down. And that's actually quite cool, and it saves quite some money, because each of the VMs that we have is like 20% of the cost of an original VM. And I calculated the simple VM is like $1 a day, and it's like 20 cents. Oh, sorry, it's $1 per hour more or less, and it will become like 20 cents per hour. Another thing that the Google Cloud supports is that if you have a workload like on that side, which is full, you might notice that you're not using the full capacity. And that's the thing, right? We have a shortage of DRAM and hardware and stuff. And it's going to cost you if you start using quite large clusters, but you're incidentally using it. That's going to cost you quite some money. So what you can do here, and that's actually quite a nice feature of Google Cloud, we have right sizing in place. So you can even say, I want 3 CPUs instead of 4, with a strange amount of gigabytes. The craziest configuration is possible in this context. Another thing is that if you use the Google Cloud, you'll also notice that we're going to recommend you at some moment, because we notice that you're not using the full capacity, and we'd like to advise you on that, because you're going to get a cost-saving marker also in your console. And another thing is, don't make just one cluster to do everything. Think about your clusters, because you separated compute power from storage, you can now think about doing the ETL stuff in a different cluster than your machine learning stuff, than your Hive analytics, then what is it, business reporting, also quite big. But as you guys probably already know, that machine learning consumes quite some power, especially compute power. And for that, you can create a different workload. You can create a different cluster with different configuration, with like lots of CPUs, GPUs, TPUs maybe, and like low on memory maybe. So this is also not something to think about when you start moving forward. And of course, we can kill the servers quite fast. So if you use it, then you say, okay, drop it and throw it away. But it's something called a semi-long-lived cluster, and actually that's very interesting. So consider this following situation. I have to keep track of the time. Consider the following situation that you have your cluster, it's production, it's version 1, whatever. And, but Hadoop has a new release coming up, which is 10x faster, or maybe has the whole complexity that you had in like 5 lines, reduces it to 1 command. The nice part is you can start doing load balancing between and canary testing. For those who know that term, that's about trying the latest greatest, but not breaking your whole production. You can create clusters with the newest version and make it part of your production process. You can even start testing, will it work for me? Will it help me? Will it create value in the end? So we have many, so you can start creating clusters in a group, and that acts as one. And just test it with your data, see if it works, and at some moment you could say, I'm upgrading all my clusters to that version. That's actually like 4 lines or 4 clicks. That's really impressive if you see that in action. So we want to see things in action, so let's go for it. I have some commands here. So first of all, do mention if it's not readable. This is readable, right? So instead of typing all the commands, I have here a cheat sheet. And let me bring it a bit longer. So first of all, what you see here is that I'm creating an, oh, it's already starting. I'm doing a G-Cloud Dataproc cluster create Rokesh demo 1 with number of workers of 5. I added some properties. We'll see what it actually is, and I added also a tag with my name on it. So at this moment, it's creating a cluster for me. So in the Google Cloud Console, you can see that it's already starting creating a cluster for me with 5 workers. It's busy doing that. But while it's creating my cluster, I can also say create another cluster. So, it's a Rokesh demo 2. It's in Europe West, yeah, whatnot. And I create another cluster. Bang. So now a second cluster is being created. I also can say, as mentioned in the beginning, I can also dive into creating another cluster. Let's call it Rokesh demo 3. And now I want to use the latest greatest of Hadoop. So we have a couple of image versions, and this is a preview version of Hadoop 2.8. So you can already start it, and I said create, bang. Now you see that 3 clusters are being created at this moment, and hopefully within a couple of seconds, you'll see an output in this context. That's it. So, and I'm not sure if it's visible, but here you can see it. In 1 minute, 39 seconds, it created a cluster in US Central. So the latency is, I think, part of why it's not beneath the 130. So now we have a cluster, and in the meanwhile, the other clusters will be coming live also. So what I can do, the next step is show you a native console. So the people who are familiar with Hadoop probably know this interface also. So what I have to do now is create a tunnel to my cluster. So I'm creating a tunnel. That's it. I'm starting Chrome. Let's see where it is. I'm starting Chrome with specifics for using the proxy that is required for doing this kind of connection. And if I go to HTTP Rokesh demo 1 and the master on 8080 cluster, I should be able to, yes, there I am. So this is the console that most of the people who work with Hadoop know. It's exactly the same kind of software. We're not adding anything to it, it's just we're making sure that you can use it. So this is the Hadoop cluster, and you can see in this one that this is the 2.7.3 release, right? So, so Chrome is giving me errors, clear. Then the next step is, okay, say I want to do native Hadoop. So that's the thing I was used to. So what I do now is I'm gonna do a local SSH. So I'm doing an SSH to the command line of my cluster itself. In a minute I'm there. Yep. And so now I'm in the US Central cluster environment. I can say Hadoop jar, and then where's the line? User lib. Let's see. Hadoop MapReduce. Let's see. Are you guys familiar with TerraGen? Ever heard of it? TerraGen? Yeah. Okay. Just one. TerraGen is like a two. It's a reference set of data that you can sort, and that's quite interesting to do some measurements on it. MapReduce examples .jar TerraGen. Say I want to have this, and I'm gonna create it in my next Amsterdam. Amsterdam Terra. Gen temp one. So what it's doing now, it's actually doing a Hadoop job on my cluster at this moment, and it's creating data. It's creating lots of data. So I think this is 100 megabytes of data in this Google Cloud Storage location. So another thing that you always have is Google Cloud Storage. So if I refresh it here, so what we're looking at is this Google Cloud Storage user interface, and files are being created at this moment. So that is a thing that's happening on the cluster, and an interesting part is that in the, where was it? Here, this one. If I refresh this one, I can see that in my cluster, it's needing some time here. Okay, it will be there in a moment, but then you can see like the default flow of all the processes that are running. This is still native Hadoop. We're not doing something special here. So another way to run jobs, because the thing is that if this one is finished, unfortunately, I can Control C it and then I'm lost, right? Then I have to restart the job again. But what we can do here also is I can fire up a Cloud Dataproc project, a job on my cluster. And this might be a long statement, but what it's doing, it's firing off a job. Sorry. It's firing off. So what we do is Google Cloud Dataproc job submit Hadoop, and then the same MapReduce example that you saw a moment ago. Only I didn't provide it parameters. The reason why I did that is to see this error log, because I did it on purpose. It's not a demo error, by the way. Hopefully nothing will be coming up also. But what you see now is that, okay, I have an error, so I have to fix it. So the next step is to fix this statement, and what we're going to do is we're going to say, sorry. We're going to say TerraGen like we just did a moment ago. And then I can say it on the Google Cloud Storage, next Amsterdam bucket, create the TerraGen temp2. Oh, did I miss something? No. Yep. So now it's submitting a job, and that's actually very cool. Submitting a job in Google Dataproc is like fun, because everything that everybody does with your system, you can record it. It will be recorded, actually. And what I can do now is, while it's running, I can go to the Cloud Console. And if I look at my clusters, I see that jobs are being fired. So I had 2 wrong jobs, apparently. I can see the log, and one is running at this moment. So another thing to do is, if I say Control-C, I'm not losing the job. Because what I can do is I can say gcloud, Dataproc, jobs, await, and then I take the job ID, Control-C it. Oh. And what it will do is reconnect to the stream that is being generated by the output. And in the end, I'm finished. So that's something that you can get. You can start your job, close your laptop, go home, and it will still be executing anyhow in the background. So another thing that I would like to show you, and I still have time, yeah, nice, is a thing called a Stackdriver. So Stackdriver is like our monitoring tools over cloud environments, if you want to. So what I'm going to do is I'm going to create a group here, call it Rokesh demo live, and I'm going to add a tag. And in my one of my first statements, that's here, I use the tag this. So the tag is actually quite interesting, because now you can combine several clusters together and have a dashboard on all the clusters in one go. Although they're totally independent, totally not related, maybe even, but you can see the complete performance of your clusters that you're running. Exist. Yep. Add criteria. Bang. Save group. Oh, this one can go. Save group. So in Stackdriver, the very interesting part is within Stackdriver group, you can create dashboards. And a dashboard is actually quite straightforward, because you can say, for example, let's see, the inbound traffic. Where is it? It's a bit slow, I don't know why, but GCE. Yeah, so we have the network inbound, we make a stacked area, and we filter on group, where the group value is equal to my demo. And then I say save. And what I can do is now, on the fly, add charts on the cluster itself. This is something that is very powerful, which allows you to indeed have an overview of all your clusters running at the same time. Of course, we have something similar also in the cluster environment, where if you click on a cluster, you can see the CPU utilization. These are apparently the jobs that I tried a moment ago. Network bytes, capacities, etc. It's everything that you can see, but the biggest difference with Stackdriver is that you can see it in one go. You can make a dashboard out of it and show it everywhere. So I think it's time to do something really beefy. So what I did before this demo, I created with TerraGen 100 gigabyte of sorting data, and I would like my Hadoop cluster to work on it. So yeah. So let's go back to this one. So this is the statement. It's the same thing. The only thing is that we're doing differently is now we're doing tera sort. So that's the sorting algorithm. It's for benchmarking, so we can see what the performance is of that. And I will do it on 100 gigabyte of data. So I submit the job, and what you see now is that it's, it's 100 gigabyte of data. It's not very easy to do that. It's going to cost some time. So what I'm waiting for now is to see the percentages go up. And if you see it in a bit, so it's going to be like every 20 seconds it's going to do 1%, which is not that fast, right? And I already created my cluster, so what to do now? So what we can do is, so while this one is doing like, say, about 20 seconds, more or less, what we can do now is we can go back to the cluster, go into the configuration, and this is the easiest thing I've ever seen. Is I say edit, let's do it, say 40. I want to have 40 worker nodes. So what happens now is the request is submitted, it's not cancelled. Yesterday I had a cancellation because I didn't have enough quota, but now my cluster is creating 40 VM instances immediately, and the moment they are available and managed, the calculation that is happening will start using it. So it's spanning from 5 workers immediately to 40 workers. And hopefully the result in a bit is that you will see that this job will go faster and faster. I'll leave it open in the background. So yeah, another thing that is very interesting to show in Stackdriver itself is if you look at something called fork rate and memory. And this is actually, let me stick to memory only. Memory used. So line chart, filter, group, save. So the interesting part is, and if I zoom in a bit, here you can now see which VM, sorry, it's not visible. You can now see which VM is taking like lots of memory. It's taking up all the memory. And what you'll see at a moment is if all the clusters come together and the 40 VMs are available, then you see them all spiking also. So actually you can see where there's a bottleneck in your framework, and you can say, okay, it might be time to add some memory or extra compute power. So that's actually quite impressive also. And another thing that I totally forgot, but is very important. So I created a cluster which was in a different preview version. So what I can do now here is I can go to tree. That's my third cluster that I created, and if the network is working, yes it is. It's actually quite slow. I'll end up in that cluster, which is apparently also running. About. You can imagine that yesterday the demo was fast. But if it's there, what I'm showing here is that I'm actually using another version of Hadoop, which is version 2.8 snapshot, which is available, which is made available by Google for you, and we're taking the latest snapshot each day. So that allows you to start, do the canary testing part. So if all the things are done, and you say, okay, it's fine. My job is going faster now. Instead of just every 20 seconds, is now every 2 seconds or something like that. You can say, okay, fine, kill my clusters. So killing a cluster or removing a cluster can be done. And that's something I would like definitely to share with you guys, is that if you have a cluster, if you say create cluster, there is always a REST interface available for that. Why is this important? Because the people found out that we need orchestration tools like Airflow and Luigi to make sure that they can interact with these kind of clusters and manage it. So for all the actions that you've seen that I've been doing so today, you can find the REST version of that. Going forward, so deleting a cluster is like selecting it, throwing it away, bang, that's it. And that's also everything that I would like to show in this demo. Let's see, I have 2 minutes. So managing clusters, what we did is we showed that we can go into the through raw clients or to the user interface of Cloud Dataproc, create clusters, jobs, and operations. We have low-level APIs versus jobs APIs. All of them, we don't want to frustrate you, right? So if you was used to Hadoop jobs, go ahead, make a day, start using Hadoop. But if you want to use a bit more sophisticated approach where jobs are not killed because you closed your laptop or because there was a network outage, then these are the other ways to go forward to. Everything is REST-based, so all the calls that are made with the gcloud command can be done through REST. Updating, downscaling, and upscaling can be done through the edit button, also through REST if you want to. Logging and monitoring is part of the platform, and even if you have multiple clusters in a big environment, which is gonna happen anyhow, you can do it. So putting it all together, reference architecture for burst loads is use the internet gateway, and then we're gonna fire off in the cloud, we use it and we throw it away. A hybrid approach is possible where you use a VPN gateway to talk and bring data back and forth and do your job wherever you want to, especially if the data is not necessarily allowed to be in the cloud. And you can go full cloud native, which in the long run would help you with canary testing, with upgrading. I would never accept an argument that says, well, you know, it's been running for 2 years, let's keep it, let's not touch it. In this case, you can start canary testing immediately and say, okay, part of my workload is going to go to that new Hadoop cluster, and we'll see if there's a performance gain in that. So if you want to get started with Cloud Dataproc, these are the links. Tutorials are available. This code sample can be made available, so find me if you want to dive into these kind of contexts. Yeah, for documentation, you can find quite a bit. I did my first presentation on Dataproc 1.5 years ago. This is more or less the same product with lots of extra features on top of it. And since then, so since the launch like 1.5 years ago, there's lots of content also to be found on Stack Overflow. Follow the discussions and find us in support. And for the rest, I'd like to thank you for your time and patience. Thank you very much.